Okay, this is part two. I didn't mean to do that. I actually hit stop of recording. I paused it to see if I could get decimals up here, and it would be too much work. So anyways, I hope you can see the end of the last recording. And I was to here. Where's my purple marker? We gotta go green. So as you notice, this guy, the only thing different between this and this is the negative. So what we're going to do, what does that negative do? Well, that negative reflects it over the y-axis. And so here's my y-axis. So it's going to take this whole thing and it's going to flip it right over the y-axis. So this spot would go here, and then everything else would just kind of go like that. Okay? So it's a mirror image on the other side. It's like this was a stick and they just flipped it. It would take that right over the y-axis right to here. And then the last thing is just add one. So I'm going to take this, I'm just going to go up one, and my final little graph would be that dotted guy right there. So I hope by watching little step by little step by little step, you can kind of put it together, because when you're trying to match the equation with the graph, you're going to have to take a look at the crazy graph. Again, they said the 12 basic graphs. Now, you're going to have them all memorized? No. They're going to give you what they generically look like, and then you'll make sense of it, okay? Packet lesson, I'll make a lot more sense of what I'm trying to say right now. I just want to go over the general rules of graphing and some of the language. So, look at all of these graphs on the board here. All right, let's just pick this green one, okay? Now, when you're asking the question, is it increasing or decreasing, you must think left to right. So, I just try to dummy it down a little bit, and I just say, okay, you're on a roller coaster. If you're moving left to right, would that roller coaster be going up or would it be going down? And it's as simple as that. So this one, increasing or decreasing? Increasing. How about this one? Increasing. How about this one? Increasing. How about this one? Decreasing. Again, left to right. So how about this one? Increasing. How about this one? Increasing. Get the idea? Let's move on to this. Is it continuous? They're all continuous because there's no break in the graph. You'll see a couple of them. They're super strange and they look like this. They look like steps. They are not continuous because there's a break in the graph. Pretty simple. And then vertical asymptotes, here's a vertical asymptote, and that guy's name is x equals 2. And this graph wants to touch it, but it never does. This is a horizontal one. Let's just call that y equals 2. This comes up, wants to touch it, but it never can. Do any of these have asymptotes? No. They have a stopping point or a starting point, but they don't have anything that they're getting near, and they can't quite cross over it. We'll explain that more later. Now, what I'd like to do is look at f of x equals x cubed. And so I'm going to erase this right here. It'll be a little messy, but oh well. Part of life. And so I'm going to get rid of this, and now I'm going to throw some negatives in here. -3, -2, -1, 0, 1, 2, 3. And I'm just going to cube them all. So that'd be 27, 8, that'd be negative though, negative. -1, 0, 1, 8, -27. Now, if I start here and move out, 0, 0, -1 would be bing, bing. 1, 1 would be bing, bing. 2, 8 would go bing way up here. -2, -8 would be bing way down here. And you can already see what it kind of is going to go up to that way a little bit. Again, the next one would be 3. Oh, this would be positive 27 in a hurry. Sorry. 3 way up to 27, so it starts screaming up. Now let's go through our little checklist. Increasing or decreasing? Well, if I pick any spot on the graph and I move left to right, increasing. Is it continuous? Pretty obvious, yes. Vertical asymptotes or horizontal asymptotes? Nope. All right. Now, the last little intricate moment here, and I've got time, but this is different. So this is saying, what's the limit? You say that first, then you say, as x approaches infinity. That's a fancy way of saying, hey, move left to right. Just like I said, when you're calculating if it's decreasing or increasing, you move left to right. This is giving you instructions to go along the graph left to right as your x moves towards infinity. That's a different fancy way of saying move left to right. But the question is, what's this even asking for? Well, it's asking for the limit of f of x. F of x represents your graph. In other words, if you travel along the graph, left to right, are you going up or are you going down? What am I talking about? This whole thing is a fancy way of saying what's your range? What's happening to your y values as you move left to right? Well, here we go. Oh, going up. So my answer would be, wow. I'm going to cheat. Positive infinity for that one. Now here comes a big old what if. What if the problem said this? What if there was a little negative chunk right there? This is saying as x approaches negative infinity. So it's not left to right anymore, but now it's right or left to right anymore. It's right to left. In other words, start somewhere on the graph, move left. Where's it going? Down. So my answer for this one would be negative infinity. You'll get used to it as we practice some, but that's new.